Hello students, today we will start the third module. In that the first chapter is Unix file APIs. This chapter it will describe how the Unix application interfaces with the files. After reading this chapter, students will be able to write the programs which will perform the following functions like creating the files, opening the files, transfer the data to and from the files, then close the file, remove files, query file attributes, change the file attributes. Like here you are able to change the permission of the file, then truncate the files. Before that we will see the different file types. First is the regular files. An ordinary file is a file on the system which will contain the data, text or the program instructions. Second is the directory file. Directories are going to store both special and the ordinary files. Directory files are nothing but files which are going to contain the other files or the other directories. Then the third type will be the FIFO file. They are also known as the named file. Mainly it will be used for inter-process communication. To perform the inter-process communication, you are going to make use of the FIFO files like a pipe here. We know already in the previous videos we have seen how the pipe device is going to work. So the output of one command will be given as an input. So to perform that inter-process communication between the processes, here FIFO file will be used. Then next is the character device file. It is used for input output device and data is transferred one character at a time. The next is block device file. It is used for input output device and the data is transferred large fixed size block. Here character and the block, it is differentiated based on how the data will be transferred. In the first case the data will be transferred in the form of one character at a time, and in the second case the data will be transferred a fixed size of blocks here. The next is symbolic link file. Symbolic link is used for referencing some other file of the file system. The next is the file APIs, which will be used to create a different files of files. Unix system provides a set of application programming interfaces. Even we can call it as the system calls, or in the short form we are going to call it as the APIs. Application, program and the interface here, APIs, which may be called by the user program to perform a systematic specific functions there. That first one is the open API is there. This API it will be used by the process to open a file for the data access. The next is the read system call. It will be used by the process to read the data from the file. The next is write to perform the write operation on the file. lseek is there to allow the random access to the file. Whenever you are using the read file, the data will be accessed in a sequentially. So if you want to access the data randomly, for example, after reading the first line, I want to read the fifth line. So in that case, you are going to make use of the lseek. Then close is there. It is used by the process to terminate the connection of a file. Then stat is there. It will be used to query the file attributes. To access the attributes of the file, you are going to use the stat. Then next is fstat is there. It is used by the process to query the file attributes. Then next chmod is there to change the file access permission. Already we have seen the chmod. It will be used to change the permission of the user, others and the group. Then chowner is there. It is used by the process to change the user ID and the group ID of a file. Utime is there, which will be used to change the last modification and the access timestamp of a file there. Then link file, it is used to create a hard link to a file. Then unlink, it is used to delete the hard link of a file. Umask is there to set a default file creation mask. You are going to make use of the umask. Then first we will see the open. Already we have seen that open is there, which will be used to open the file. Okay, so this is the syntax for using the open system call. Open, it is going to return the integer value. Then open, it is going to take a character constants, the path name where the file has been present, the path name, it might be in the absolute form or the relative form. Then the access mode, in which mode you are going to open the file, whether you are opening in the read mode, write mode, or which mode. Then the mode permission, which all permission you are going to have, that will be specified here. We are going to see these two options in detail. Then just remember one thing, whenever you are going to make use of the open APIs, compulsory you have to include these header files. The first one is hash include sys slash types.h, hash include unistandard.h, then the hash include fcntl.h. fcntl is the file control. So compulsory you have to include these three header files whenever you are going to make use of the open system call. The path name argument is the path name of the file to be created, and the mode argument is same as for the open API. Okay, open API can use both create and the open regular files. Okay, so create API has become the absolute here. The create function can be implemented using the open function. Here the first argument will be the path name is there, which is going to specify the name of the file, and already we know that the path can be specified in the two forms. The first one is the absolute and the relative mode. Then second one is the access mode. Okay, so for that you are going to use the flags. The first one is the O underscore RD only, means you are going to open the file for read only purpose. Then WR only, you are going to open the file for write only. Then read and write, you are going to open the file for read and write there. Append, appends the data to the end of a file. Then create is there, it is going to create the file if it does not exist here. Then execl is there, where this option it will be used with the create if the file exists and the call fails. The test for existence and the creation if the file does not exist here. Execl, what it is going to perform, it is going to check whether file is already exist or no. If it does not exist, then it is going to create a file there. Then truncate is there, if the file is already exist, it is going to discard the file contents and sets the file size to the 0, means the contents of the already existed file will be get deleted. Then the third argument was the permission. Okay, here it is required only if the oCreate flag is set in the access mode argument. So here three types of users are there: user, group, and the others. Okay, and three types of permissions are the read, write, and the execute. If you want to give the read, write, execute permission all to the user, just you have to use this ones here: read, write, and execute to the user. If you want to just give the read permission, read to the user, write to the user, and execute to the user. Similarly for the groups, if you want to give the read, write, and execute to the group, read to the group, write to the group, and execute to the group. Others same, read, write, execute to the others, read to the others, OTH here. W, write for the OTH and execute for the OTH. Okay, then next, how you are going to identify the errors. Okay, here externally you have to identify the errors, means here you have to check whether the file has been opened or no. Okay, so while explaining here I have told the open system call is there, it is going to return some integer value. Two types of integer value it is going to return. If file is already created, file is opened properly, then it is going to return the file ID. Okay, then if the file is not opened, that system call is get failed, then it is going to return the -1 there. Okay, so just here example what we are doing, int fd, I have taken one integer value, then open file name, here I have to specify, I have to I am opening the file in read mode only, then 644 is the permission. Okay, 644 permission I am giving, okay, to the user other and the group. Okay, so here see, this is the code for error checking. If fd is less than 0, okay, if fd is less than 0, whatever the open file is going to return, if it is less than 0 means error in the opening file, then that error you want to display here, which is stored in the error number and in the standard errors, then you have to return -1. Just we'll see here. How can we tell if the call is failed? The open system call, it is going to return the negative number. Okay, if the open system call is failed, then it is going to return the negative number. So based on that only you are going to check whether the error has been occurred, means the file has been opened properly or no. Then how can we tell what was the error? So using error number is there, a global variable set by the system call if an error has occurred. Okay, then which has been defined in the error number.h. So due to that we have to include that header file here. Then use the standard error to get the string description of the problem and the p error to print the string describing the problem here. Thank you.